was just kind of like a practice day. So there were some things in our packet that we didn't do. So you should have notes on the first half through 6 on the first page. I'm just going to kind of go over what you should have done in your packet, what's being graded in your packet. So essentially, this is page 1. That's all you had to do on page 1. That's a point, right? We didn't worry about the back of that page. Page 2, you should have through number 6 done. So there's 2 points total. Another point there. We did not worry about the back of that one. Do what? This number 2? This is like the 3rd page, the front of the 2nd page. So we did do that. Yeah, that you have it. Yeah. So after I turn now, I'm essentially on the 3rd page. This is a 3rd point. So 1 point, you should have this whole page done. We did that together. Now here is where you should have been practicing yesterday. So you should have done 7, 8, and 9. If you haven't, make sure you highlight it. Make sure you make note of this. This is the back of the 3rd page, right? If you're turning around along with us, then hopefully you're following. This says using prime factorization at the top. Yes, so you should have done 7, 8, and 9. And then you should have finished or completed the greatest common factor maze. Guys, I'm just turning page by page. Quit being lost. Stay with me. So turn the page. On the back of the greatest common factor maze, you should have done 1 through 8. So some of you may have done a few here already, but you should have done 1 through 8. You don't need to worry about using factor trees or prime factorization. You just needed to do them, finding the greatest common factor. So turn now to where it says multiple. We did these notes together. That should be done. Then turn to the back of the multiple notes and just 5 and 6 you should have done yesterday. Just practicing again. You had an opportunity to practice a little bit more. And then the least common multiple maze should have been done. And 1 through 8 on the very last page. So if I'm adding up points, starting at the beginning, I've got 1, nothing on the back page, 2, nothing on the back page, 3, 4, something on this back page, 5, 6, something on this back page, 7, something on this back page, 8, 9, and 10. So a 10-point packet. If you haven't finished, make sure you complete that. Otherwise, if you don't turn it in at the end of the hour today, I'll probably have you turn it in when I get back on Thursday, because I will not be here tomorrow. I have to go to a funeral for my sister-in-law's mother. She passed away. So be sure you have those pages done. And then we're going to move on today. We're going to be working in our new books, actually. So I'm going to pass those out now. Be sure that you put your name. I would suggest opening the front cover and putting your name here. So your name, and then maybe Lob, and then hour 4. Yeah, for sure. And then we're gonna move along here. So we've done quite a bit of this already. We've done modules 1 through 3. So we're actually turning to module 4. And we're gonna start there. Yep, you can access this through Clever, McGraw-Hill, Reveal, right? This is Reveal. Instead of Alex, you would click on the Reveal. So module 4 starts on page 175. 175. It's not too bad. This is like essentially the last module in volume 1. So pretty soon we're gonna have to get volume 2. It's just really funny that they didn't show up till now, right? Actually, they showed up before module 3, but we already had it printed. So, and in fact, I actually have module. Oh no, I think that's 8th grade module 4 printed, but I gave them the textbooks too, so they would have it in color, and you can have it in color. Isn't it beautiful?
No, it's not.
All right. So you can see what we're going to be learning about with rational numbers. Hopefully a lot of it is review, but we're going to be writing fractions as decimals, fractions as decimals rather, adding rational numbers. So like adding decimals, adding fractions, subtracting rational numbers, multiplying rational numbers, dividing them, simplifying expressions involving rational numbers using the order of operations, which you all remember, of course, and evaluating algebraic expressions involving rational numbers. Okay, so that was page 175. I am turning the page. Here is some vocabulary that you're gonna be accountable for. So bar notation, repeating decimal, multiplicative inverses. Remember, that is what we would multiply it by to make it 1, which we call the reciprocal. So if we multiply something by the reciprocal or its multiplicative inverse, it would equal 1. So if I multiplied 1/2 by 2/1, I would have 2/2, which would equal 1. So the multiplicative inverse of 1/2 is 2. Or the multiplicative inverse of 2 is 1/2. So that's kind of a fancy word for reciprocal, which is also a fancy word for flipping the fraction.
Yeah.
This is all review. We're on page 176 at the time. Terminating decimal, rational number. Are you ready?
No.
So writing equivalent fractions, graphing mixed numbers on a number line. Those are all things that you should know how to do. All right, starting in 4-1. Here on page 177, page 177. I can divide rational numbers and convert fractions to decimal equivalents using division. Oh man. So the rational number is any number that can be written in the form A over B, where A and B are integers and B does not equal 0. It would be undefined, right? If we were dividing by 0. The table explains why each number is a rational number. So -15, you can write -15 as the ratio -15/1. You can write -8/10 as the ratio -8/10. -1/8. You can write -1/8 as the ratio -1/8. 28%. Do you guys remember what percent really means? Per what? Percent quite literally means per what? What's a century? How many years are in a century? Per 100. And there is how many cents in a dollar? 100. Percent. So percent means per 100. So anything that says 28% can be written as the ratio of 28 per 100 or 28 hundredths. And if you know, I think we went over a lot of this. If you know how to say your numbers, you can easily write 28 hundredths as a decimal, right? Your 8 needs to end in the hundredth place. Tenths, hundredths. Remember after your decimal? Yes, no, maybe so. All right.
Absolutely not.
So rational numbers written as decimals. We're gonna skip that exploration at the moment. I really want to get some notes done because tomorrow I would like you to do the practice while I'm gone so we can go over it right quick when I return Thursday and we can keep moving on. So I'm going to go over the learn and the examples today in hopes that you can use them to do the practice tomorrow. So you're going to start the hour with Alex and then you're going to complete the practice tomorrow. Does that sound fair? I do. Not right this second, but you can use your pencil on the inside cover. I promise. All right, so rational numbers written as decimals. Any fraction can be expressed as a decimal. So you're going to probably want a calculator, I would say. Or I'm going to do a few with long division just to show you. And then eventually, when they get harder, we'll be using a calculator. But the decimal form of a rational number either terminates in zeros or eventually repeats. Repeating decimals are decimals in which one or more digits repeat and can be represented using bar notation. A bar is drawn only over the digits that repeat. You guys have seen this, right?
No.
Repeating decimals? Yes, you have. The following decimals are written in bar notation. So negative 0.4444444444444 on, we would just write as negative 0.4, and that digit that's repeating, we put bar notation over it to show that it's repeating. Same thing with 2.4343434343, except since the 4 and the 3 are repeating, we use the bar notation over the 4 and the 3. So we're going to practice using that bar notation now. So I'm going to write 0.1 and then I'm going to put the bar over it because that 1 is repeating. Here, I'm on page 178. Remember, if I'm writing, you should be writing too. It's good practice. Remember, the only way we learn math is to do math. Okay?
Yeah.
Yes, it is a 1.
Now
Now I have 0.61. Do I draw my bar over the 6 and the 1? No, only the 1 is repeating, so I'm careful to only put my bar over the 1. However, when I write 0.61 here, since they are both repeating 61, 61, 61, my bar notation has to go over them both.
Oh wait, it's not just 2 steps.
Here, I would just write 6.16. Is anything repeating? What? Zeros repeating. I can write as many zeros as I want to after a decimal. Does it change my decimal?
No.
No, so I can just write it like this. If I put a 0 before the decimal, would it change my number? Yes, that would be like multiplying it by a 10. Oh, thanks. Don't do it. All right, this one's tricky. 6.16116116111. So what is repeating? 611. So I actually have to put the 6.1 and then I have to write the 611 and the 611 is what's repeating. That's a little confusing. 6161 611 166 116. Huh. All right. So every decimal can be considered a repeating decimal. Decimals with a repeating digit of 0 are also called terminating decimals. So this is a terminating decimal. Because the repeating zeros in a terminating decimal are usually truncated or dropped. When we're talking money, though, if I had $2.50, I don't usually write 2.5, right? Even though that is what it means, $2.50, right? We usually do include the 0 there. Does that make sense? All right. For example, the terminating decimal 0.250 is written as 25 hundredths or 0.25. The decimal 0.250 repeating can be considered repeating because the digit 0 repeats. I think that's kind of silly, but whatever. So all decimals are repeating decimals, but those that it's just the 0 repeating, we call terminating decimals. Yeah. Write 1/40th as a decimal. Determine if the decimal is a terminating decimal. So we're going to divide 1 by 40 using long division. Why? Well, what does that fraction bar mean?
Division.
Divided by. That fraction bar means divided by. So as you get older, you are going to be showing division with a fraction bar. So 1 divided by 40 really looks like this. 40 into 1. Notice they put the decimal here and they added a bunch of zeros for us. So I'm going to bring my decimal straight up. Can 40 go into 1? No. So we would put 0 times right above the 1. So then I'm moving over. After the 1, I'm looking at the 10. Can 40 go into 10? Still no. So I'm putting 0 times above the first 0 because that represents the 10. Can 40 go into 100? Yes. How many times could 40 go into 100? 2 times. So I'm writing that above this second 0 because that is showing the 100, right? So 40 times 2 is what? 80. So I'm subtracting 80 from 100. It is 20. Now what do I do with long division? Drop them? Well, I'm going to bring them down, right? So I'm going to bring down the next digit, which is a 0.
Too small.
Yeah, I mean, if it helps you to rewrite the problem larger for you to follow through, for sure do it. How many times can 40 go into 200? Well, how many times can 4 go into 20? 5. So 5 times 40 is what? It is 200, right? Exactly. So we could end it there. We don't need all the other zeros. This 0 would just repeat on and on and on. Do you see how they wrote it? So 1/40th. So 40 goes into 0, 0 times, 0 times. We could carry it on. It was. That's the beauty of these. All of the examples start out and they always give you the answer below it. So you could follow through on your own this whole text and teach yourself. Isn't that beautiful? All right, so part B, determine if the decimal is a terminating decimal. The decimal ends with repeating zeros, I think they want. I don't know. So this is a terminating decimal. All right, so our check is, which of the following is the decimal form of -1/25th? Well, we're going to save the negative part for the end. It's going to be a negative decimal, obviously. But we want 1 divided by 25 because that's what that fraction bar means. We would read it from top to bottom because we're English. There might be some places that read things from bottom to top, but we're going to read it straight from top to bottom. 1 divided by 25. So we're going to set this up just like we did here above there. 25 into 1. And knowing that it's going to be a decimal, I'm going to add as many zeros as I want. I could keep on going with the zeros. Can 25 go into 1? No, only 0 times. So I'm going to put a 0 above the 1. I'm going to bring that decimal point straight up. Can 25 go into 10? Nope. So I'm going to put a 0 above that. Can 25 go into 100? Yes. 4 times. 4 times 25 is 100. So then it would go into a bunch of zeros, right? So I would truncate it. The 4 is not repeating. It is negative. A, B, C, or D? Tanner. Unhelpful. A, right? Does that make sense? Do you see how we could do long division? Do you understand how to do long division, or are you skipping right to a calculator? What do you think? Probably a calculator. All right, determine if it's a terminating decimal. If it ends in repeating decimals, it terminates. So is it terminating?
No.
Yes. Yes, it's terminating. Everybody good on example 1? Hopefully. Example 2. Write -5/6 as a decimal. Determine if the decimal is a terminating decimal. Write the fraction as a decimal. So remember, the bottom is always going into the top. So can 6 go into 5? No. Bring up your decimal. Can 6 go into 50? Yes. How many times? This is where it's important to know your multiplication facts. 6 times 8 is 48. So 50 minus 48 is 2. Bring down the next 0. How many times can 6 go into 20? 3 times. What's 3 times 6? 18. So 20 minus 18 is also 2. Bring down the 0. 6 times what can go into 20? Same thing over and over again, right? So if I brought down another 0, what do you think's going to happen? The same thing. So what number is repeating? The 3. So I can truncate it and just use my bar notation over the 3. The remainder of 2 will repeat, so the 3 in the quotient will also repeat. Oops, I forgot my negative sign. So negative 5/6 is equal to negative 0.833333333. Determine if the decimal is a terminating decimal. The remainder is never 0, so the quotient will have a repeating 3. Because the decimal repeats, write it using bar notation. So they said negative 5/6 is equal to negative 0.8333 ... or negative 0.83 with the bar over it. This is not a terminating decimal. So in our check, remember, we're always going to take the bottom into the top. Try this. Can 9 go into 5? Can 9 go into 50? How many times? Bring the next 0 down. So we said 9 cannot go into 5. I'm bringing up my decimal. 9 goes into 50 how many times? 5. 9 times 5 is 45. 50 minus 45 is 5. Uh-oh. Bring down the 0. 5, just 45. So if the remainder is repeating, so is our decimal. So this is equal to 0.5, and that 5 is what's repeating. Is it positive? It's positive. Determine if the decimal is terminating. No, it's a repeating decimal. So this would be no. Because it's repeating. No, we're not done for the day. I want to walk you through these apply in case you want to try those out tomorrow. So this is on page 181. 2 vendors at a craft show are selling signs. The lengths of signs offered by Signs and More and Woodworks are shown in the table. Each sign has the same price. Henry wants to buy the longest of each kind of sign. From which vendor should he buy each style of sign? So rounded corner signs. Make sure you understand the question. What is the question? If each sign has the same price, he's got to get more. So which is bigger, 1/8 or 25/100? Some of these decimals you should know. You should know that 25/100 is equal to what fraction? 1/4. And we should know, thanks. We should know that, you've got a couple minutes, but that 1/4 is smaller or bigger than 1/8? It's bigger, because if I had 1 out of 4 pieces, well, think about a pizza. If I cut it into 8 pieces and I cut that same pizza into 4 pieces, the 4 pieces would be bigger, right? So I didn't have to split it with as many people. So if he wants bigger, which one would he want to buy? The quarter. Yep, the Woodworks one. So I'm just going to circle. I think we can just talk through this. But some of these, you might have to change this, right? You could do 8 into 1 to get your decimal. So 8 can't go into 1. I'll bring up my decimal. 8 goes into 10 once. Oh, look. 8 goes into 20 twice. Bring down your decimal. And 8 goes into 45 times. So this is terminating because there is no remainder. So this, you could look, is smaller than 0.25, right? So you can change them in. Now, here's a tricky one. Which one's bigger, 16 3/10 or 16 1/3? You can go back. Which one's bigger? So let's look at 1/3. 3 into 1, right? I'm using some scratch area here. 3 cannot go into 1. 3 goes into 10 how many times? Which is 9. Bring down the 1. Uh-oh. 3 goes into 10 how many times? 3 goes into 10 how many times? So which is bigger, 0.3, 16.3 repeating, or 16.3? Good, because this is 3, 3, 3, 3, 3. There's actually some in the hundredths, whereas this has what in the hundredths place? A 0, right? We could put it, this would have a 0 in the hundredths place, where this one would have a 3 in the hundredths place. Okay, so he would want to pick Signs and More if he was buying the square corner sign. So it's very important that you know how to change them back and forth, because they might trick you on that. So here's your check. During field day, a school has a long jump contest. This is on page 182. The top 6 results of the competition are shown in the table. The teacher wants to award a ribbon to the longest jump by both a sixth grader and a seventh grader, as well as a trophy for the longest jump overall. Who receives the ribbons? Who receives the trophy? So we'd have to figure out, should we change them into decimals to compare them all? I think that's the goal here. So we need to change a few of these into decimals. All of their ones places are the same, so we have to look at the decimals. So 5/8, 8 into 5. Let's do that real quick. 8 can't go into 5. Can 8 go into 50?
Yeah.
6 times is 48. Bring down the 0. 2 times is 16. Bring down another 0. 5 times is 40. So this is 9.625. 2/3. That's one you should know. 3 into 2. 3 goes into 2 no times. 6 times is 18. Look at 6 times is 18. So what's repeating here? So this is 9.6 repeating. So 6, 6, 6, 6. And this is 3/5. Well, I would change it into tenths. So 6/10 I would just write as 9.6. Because I know how to do that, right? And you should too. All right. So we have a couple more minutes. Let's look.
1 minute.
Wants to award a ribbon to the longest jump by both a sixth grader and a seventh grader. So who's the sixth grader with the longest jump?
No, it's Trevor.
So we're looking here, here, and here. Which one's the longest?
Trevor.
Trevor. So the sixth grade winner. Who's the seventh grade winner? What's Luna, right? 6, 6, 6, 6, 6. And who is the one with the longest jump? The sixth grade winner, Trevor, right? This is the trophy. Tomorrow, you are going to do pages 183 and 184. All right? Have a wonderful Tuesday and Wednesday.